Hi guys, welcome to my presentation. My name is John Maldonado. I am a student at the University of Colorado Boulder. To start off with poster, the title of my poster is Changes in Discomfort and Maximal Force in Response to Static Stretching. But the purpose of our project was to determine if stretch-induced changes in the sensation of discomfort are associated with changes in range of motion or maximal force production. So a little bit of background on how force is produced. One, motor unit recruitment. Motor unit recruitment is basically a motor neuron and all of the fibers that it innervates. The larger the motor unit, the more muscle fibers it innervates, and therefore the more force production it produces. Another form of force production is rate coding. So this is the firing rate of action potentials. So a higher stimulus will have a higher frequency and therefore will produce a higher force production. One last one is the length tension relationship. So this is the idea of how flexed or extended your muscle fibers are within the myofilaments. So talking about myosin and actin, every time that actin binds with a myosin head, that is called the cross bridge, and essentially the more cross bridges that there are, the more force production there is. So essentially, muscle force tends to go down after static stretching, and what we were trying to see in this project was to see if an individual's discomfort follows the same trend or similar trend. So our study consisted of 2 days of data collection. One was our control day, which is shown here in red, and one was our stretch intervention day, which is shown here in blue. Our experimental setup, it can be seen here where we had participants lay down in a prone position, and they were strapped in with their right leg onto this dynamometer. We had participants do around 3 to 5 MVCs. Out of those, we took the peak force and then took percentages where they would do trapezoidal or ramp contractions at different percentages. One is here at 10% and 30%. After this, we tested their range of motion. So here on our stretch intervention, we had participants choose whatever stretch they would like to do, but we were just making sure that they were getting an ample stretch with some breaks in between. After this, we tested again their maximal range of motion. After these trapezoidal contractions, we did some more MVCs and again took their peak force and then took percentages of that peak force for their rest of the trapezoidal contractions. The places where we took an individual's discomfort rating was after MVCs here, after maximal range of motion here, again maximal range of motion here, and then again after these MVCs. So for our results, we saw that there was a 77.5% of the resample data showed that there was a significant variation between stretching versus our control day. So hence MVC force was largely more variable on the stretching day. But unfortunately, there was no significant correlation between pain measurements and maximal stretching or maximal force. Some theories that can contribute to pain and sort of the neuromuscular system is there's one where there's muscle spindle properties that can cause a change in pain receptors. The second one could be a feed forward mechanism because participants know that they're about to perform activity that is uncomfortable. Another theory could be that stretch causes a change in the central nervous system. So after performing stretching, there can be sort of a more central mechanism where there's a suppression in the sensory neurons around the stretched muscle. So to conclude, our findings suggest that there is a significant variability in not only force production after static stretching, but also self-reported ratings and discomfort. Although it wasn't significant. The variability in between participants is important to consider when conducting future stretch research. Thank you.